graph the horizontal asymptote, which is y equals 1, which is the dashed line horizontally, and then the vertical asymptote was -1, which is down here, and the other one was 3, so there's the other dashed line. And then I had the points for the x-intercept, which is -2 and 2. Oh, no, -2 and 1. And then I had the y-intercept was, what was the y-intercept?
0,2/3, I think.
Oh yeah, 2/3. So that's like in between 1 and 0. So that's other intercept. And then I plugged in some numbers so I can like find out how the graph would look like. So I plugged in 2, and then I ended up with -1.33. So then I plugged that in the graph, and then I didn't check for -0.5, but then I graphed it in the graphing calculator how it looks like. So I went through the horizontal asymptote, so I just drew a line,
Right.
points, but I didn't check. And then for the other one, since there's a vertical asymptote, so I checked for -3 to check where the graph would look like for the other point. And then I ended up with 0.33, and I plugged that in. So I graphed it for -3 and then 0.33. And then I drew the line. And then I did the same thing for 4 because I wanted to see where the line would end up, on the top of the horizontal asymptote or the bottom. So for 4, I ended up, when I plugged in 4 for x, I ended up with 3.6. So it gave me a point on top of the horizontal asymptote. So I just drew a line for that, and then that's it.
Perfect. Great. Anybody has questions? Great job, Rena.
Thank you.
Let's see. Santiago wants to present 27. Let me make you a presenter. Yeah, go ahead, Santiago.
Hi, good morning. Okay,
Good morning.
just give me one second. Share application screen. Okay. Okay, so I'm going to present from homework number 6, the problem number 27. So here it is asking us to factor the polynomial and use the factor form to find the zeros, then sketch to graph. So
can you share your screen with us?
Oh,
Who's the middle one? Share application / screen.
Oh, okay. Can you see
Not
this?
Not
Oh,
yet.
my bad. I'm sorry. Right.
Okay.
So, as I said, it is asking us to find the polynomial and use the factor form to find the zeros and sketch the graph. So here's the problem. So what I did first, I decided to factor out x, which I did. Then I rewrite minus x as 2x minus 3x. So then I got the group terms, the first and third, and the second, fourth. I did that and I got this. So then I decided to grab that here, and to find the zeros, I did px equals 0. I did that and I basically found the zeros. So the first one is 0, which is right here, 0, 0. 3 zeros right here, and x minus 2, which is 0 right here. And that's how I did it.
Okay, that's great. That's great. But how do you know the end behavior looks like this? How do you know the graph look like this?
Oh, I also went to Desmos.
Oh, I see.
Yeah, so just to verify, yeah.
Okay.
And
Or you can observe the function. Right? The function is the x cubed. It's a polynomial of r degree 3.
okay.
Polynomial r degree with the leading term being positive, because the leading coefficient is 1. That means this term is positive. That means with our right hand up, left hand down graph. Then in the middle, some wiggles.
Oh, so that's the other way to do it?
Right,
Okay.
that's for odd degree polynomials
Oh,
with positive leading term. The
I see.
negative leading term is left hand up, right hand down graph.
Mm-hmm.
If it's the even degree polynomial with a positive leading term, it's both hands up, then with wiggles in the middle.
Oh,
The
okay.
even degree polynomial with the leading term negative, both hands down
All
with
right.
wiggles in the middle. So that's the end behavior. Then in the middle, there's some wiggles. Wiggles
Okay.
in between of those zeros.
Okay.
All right, great job, Santiago.
Thank you so much. I'll practice your way too. All right. Thank you.
You're welcome. Okay, anybody else? Anybody has any questions? All right, so today, if no questions, I'm going to talk about some new material today. We're going to new function. Okay, we're going to chapter 4. We're going to chapter 4. Chapter 4 talk about exponential functions and the logarithmic functions. And those two functions are very closely related, like brothers. So if we know one, we know the other. They are basically inverse functions with each other. So let's go with exponential functions first. So exponential functions has this form, standard form, all right? F of x equals to some number, let's call a, multiplied by another number, and this number is raised by x, right? So a number multiplied by a base. So b raised by x. B is also a number raised by x. So now x appears in the exponent. That's how it gets its name, exponential functions. All right. Why it's called exponential functions? Because x appears in the exponent. X appears as an exponent. Let me give some example. So remember, maybe you have learned doubling time, halving time in statistics class, right? We have 2 raised by x. This is an exponential function, 2 raised by x. Well, let's give some values. Let's think about the f of 0. F of 0 equals 2 raised by 0. Well, anything raised by 0 is 1. Right? Well, let's give more. Let's maybe say 1, f of 1. F of 1, so x equals to 1. This is 2 raised by 1, well, which is just 2. So we can keep going. F of 2 would be 2 raised by 2 would be 4. F of, let me just do more, right? Let's just do more. So f of 2 will be 2 squared, which is 4. F of 3 would be 2 cubed, would be 2 raised by 3, would be 8. So maybe some of you have taken statistics class talking about doubling time. Each time it doubles, right? 1 becomes 2, 2 becomes 4, 4 becomes 8. So this is exponential function with base 2. So base is 2. So each time it doubles. Or halving. Another function is f of x. Now let's call g of x. Raised by 2 raised by -x. Or we can understand as 1 over 2 raised by x. So half raised by x. So this is halving. This is halving, right? Let's evaluate g of 0. G of 0 will be half raised by 0, right? Anything raised by 0, still 1. Or g of 1. G of 1 equals to half raised by 1. Or 2 raised by negative 1, right? Which is just half. Or g of 2. That's half raised by 2, which is a quarter. G of 3 equals to half raised by 3, which is 1/8. So we say this time, each time is being halved, right? Half of 1 is half. Half of a half is a quarter. Half of a quarter is 1/8. So on and so forth. So in statistics, we call this doubling time. This is a halving time. So both are exponential functions. Both are exponential functions. And this one we call exponential growth because the y value increases as x value increases. So we call this one exponential. You know, for this class we don't really care, but we care in what? In statistic class. So this one is called exponential growth. Exponential growth. And this one is called exponential decay. Right? Exponential growth have a graph looks like this, going upward as x going upward. X goes bigger, y goes bigger. Exponential decay, x goes bigger, decreases. X goes bigger, but the y value goes smaller. So we call this one exponential decay, this one exponential growth. All right, let's see some more examples. So we have here f of x equals 2 raised by x. All right. So see here 2 raised by 3, that's 8, 2 raised by 10, that's 1024, 2 raised by 30 is a huge number. You see the difference from polynomial functions, right? This one is a quadratic function. Quadratic function x appears to be a base. And then x has exponents, so x raised by 2, x squared. But exponential function x appears in the exponent. The base is a number. That's the difference. So standard form, f of x equals to a raised by x. Well, here, you know, sometimes we have a number multiplied by it. All right. But for now, just use this simple case. Just a number raised by x. So example 2 raised by x, 3 raised by x, 10 raised by x. All right. So the base here is 2, base here is 3, base here is 10. And sometimes we may say this, the function, let's call it k. K of x equals to e raised by x. So this e is called a natural base. So this, when you go to calculus class, this happens a lot. Okay, this is natural. So e is an Euler number, so we call this a natural base. E raised by x. E is 2.712a, just like a number pi. E is an irrational number. So let's evaluate some exponential functions. Let's say here we have f of x equals to 3 raised by x. What's f of 2? F of 2 is 3 raised by 2 equals 9. What's f of pi? F of pi is 3 raised by pi. What's f of negative 2 over 3? f of negative 2 over 3 is 3 raised by negative 2 over 3. You know, we can use calculator to evaluate. What's f of square root 2? This is 3 raised by square root of 2. Also, we can punch into calculator to give approximation. So here, let's compare those two. Right? We have f of x equals 3 raised by x. So the base here is 3, and 3 is greater than 1. Compared to g of x is 1 over 3 raised by x. Right? 1 over 3 is less than 1. So the base here is less than 1. This base is bigger than 1. So for a, 3 raised by x, that's this graph. Right? We call this exponential growth. 3 raised by x. So if the base is greater than 1, you always have this kind of shape. Right? It's always exponential growth. If the base is less than 1, that's exponential decay. That's exponential decay. When x number becomes larger, the y value, the function value, becomes smaller. We can use tables, right? Give some points to the graph. But for us, let's just try to remember. You know, we have this common point. This point is 0, 1. Right? This point is common point, 0, 1. Because anything raised by 0 equals to 1. 3 raised by 0, that's 1. 1/3 raised by 0, also 1. So those both graphs cross this common point, 0, 1. And notice this. Notice these functions. Those two functions are inverse with each other. Reciprocal, right? Reciprocal. Let's say reciprocal with each other. So 1/3 of x we can write as 3 raised by negative x, right? 3 raised by negative x. So g of x we can write as f of negative x, right? F of negative x. Right, let's see some examples here. So you see, if the base is bigger than 1, so we have 2, the base being 2, base being 3, base being 5, base being 10. Or we can have a base being e equal to 2.712 something. It's also bigger than 1. The graph goes from lower here up to, going from the second quadrant to the third quadrant, but never touches x-axis. All the value will be above x-axis, but it will never touch x-axis. So the graph goes very, very close to x-axis, very, very close to axis. So we should go this way. I should draw this way, right? Then cross this common point, 0, 1. Keep going up, right? This goes on forever. All right, so this is exponential growth. When the base is bigger than 1, we have this kind of shape. On the other side, we see if the base is 1/10, 1/5, 1/3, 1/2, or 1 over e, that means the base is less than 1. The graph goes from second quadrant to the first quadrant. So the graph goes this way. The graph goes this way. And this is called exponential decay, because the y value becomes smaller when x value becomes larger. And you see every graph passing this common point. 0, 1. Because it doesn't matter what the base is. Any number raised by 0 is 1. So they're all passing this common point. Right? So I have these two graphs, right? So a always greater than 0, all right? In here, in exponential functions, we will never deal with a negative base. The base is always positive. And we don't want to deal with 1, because 1 raised by anything will be 1, right? That will be a constant function. So when a is bigger than 1, we have this upward shape. When a is less than 1, we have this downward shape. They're all passing the common point, 0, 1. So this is a base 2, right? Or base 5, right? If x equals 2, 5 squared, no, if x is 2, 5 squared is 25. This is base 1 over 2, right? If x equals 3, 1 over 2 raised by 3, that's 1 over 8. Right, so we say A, because we have a base being squared, so x equals 2 is something being squared equals 25. That means the base has to be 5. 5 raised by x. If x is 2, that's 5 raised by 2, 25. F of 3 equals to another base raised by 3 equals to 1/8. You know, cubic root both sides, we have half, so equals to half. So function equals to half raised by x. So this is a graph of half raised by x. This is a graph of 5 raised by x. Let's see these transformations. So we remember those graphs as reference graph, as a basic graph. Now let's see some other graphs. Let's see this function. It's 1 plus 2 raised by x, right? We know how to graph 2 raised by x. So the blue one is 2 raised by x, right? It goes upward. It passes the common point 0, 1. It keeps going upward, exponential growth. So 1 plus 2 raised by x is saying this is a y value being lifted up 1, right? So this is a vertical shift, vertical lifting. So plus 1, right? Plus 1 is a vertical lift. Because it's positive, 1 is positive, so vertical lift. So before we have the 0, 1 point, now be moved to 1. So every point been lifted up 1 unit. Every been lifted up 1 unit upward. So this transformation is vertical lift. Let's see the second one. Second one is a negative 2 raised by x. So the function is being negative. So 2 raised by x is this graph, is this piece. Now every y value is being negated. It's being negated, so putting negative signs up front. Before was 0, 1. Now it becomes 0, negative 1. So the graph becomes now. So it's a reflection over x-axis. Every positive y value now becomes a negative y value. So this is a graph of negative 2 to the x. Let's see the third k equals 2 raised by x minus 1. Well, let's rewrite this function actually. What is this function? If we rewrite it, that's 2 raised by x times 2 raised by negative 1. What's 2 raised by negative 1? That's half, isn't it? That's a half of 2 raised by x. That's in the beginning. Remember, I was talking about the standard form was a times b raised by x. I said this is standard form. You see now the a is a half, b is 2, right? You see, you have a number before it. We have a half. The base is 2 raised by x. So this function can be written as this. Or it can be thought as a horizontal shift. Horizontal shift. Right? So x value is being shifted to the right 1 unit because x minus 1. X minus 1. X value being shifted 1 unit to the right. So before we have 0, 1. Now it becomes 1, 1. It becomes 1, 1. So this is the horizontal shift because the x value being changed, x minus 1. So minus means shifted to the right. So 0, 1 becomes 1, 1. And every other point being shifted, so the whole graph is being pushed 1 unit to the right. Okay, horizontal shifting, reflection over x-axis, and vertical shifting. Those are 3 examples, are very good examples to remember. Any questions? Also in statistics class, we have this compound interest rate. Okay? This we can understand as a function, right? A of t is a function in terms of t equals the principal, the money we put in the bank, multiplied by 1 plus r. R is annual interest rate divided by n. N is how many times the interest is being calculated each year. Then raised by n times t. Right? So this is to calculate, if we want to know how much money we can have by depositing certain amount of money with a certain percentage of interest rate in certain years. Let's see an example. Let's see, a sum of $1,000 is being deposited, right? And with a rate of annual rate is 12%. So let's find some amounts after 3 years. If the interest is compounded annually, that means n equals to 1. Compounded annually means n equals to 1. Just one time. The interest is being calculated each year, once each year, annually. So this is compounded annually. Semi-annually means n equals to 2. Because semi-annually means half of a year, right? So that means n equals to 2. Quarterly, that means n equals to 4. So each quarter, so I have 4 quarters in a year. So n here represents the number of times interest being calculated, okay, compounded, being calculated. So if it's annually, that means the money of $1,000, the interest being calculated only once, then calculated and then add to your account. So in the end of the year, you have $1,120. Semi-annually means calculated twice, right? Quarterly means calculated 4 times. So that's N. R is the interest, okay, interest rate, annual interest rate. You see this annual interest rate, 12% here. T represents the number of years. P is the principal, is the money we put into the account. A means amount of money after certain years, after T years, okay. Amount of money after T years. Okay, let's calculate this. So P equals to 1,000, R equals to 12%. 12% we can write as 0.12. And after 3 years, that means T equals to 3. Right? Let's calculate it annually. Annually means N equals to 1. So we plug into the formula. 1,000 times 1 plus 0.12 divided by 1, parentheses. Then 1 times T is 3. We have to use calculator. Okay, we punch into calculator. We punch it inside first. So we do 0.21 divided by 1, that's 0.21. Then we add 1, that's 1.12. Then we raise by 3. Then we multiply by 100. Okay, the order of operation, we follow pandas. After the calculation, we get $1,404.93. Semi-annually, N equals to 2. So after the calculation, we have $1,418.52. So it's a little bit more than calculated annually. Quarterly, we get a $1,425, even more. Monthly, n equals 12, so get more. Daily, so every day being calculated, we'll get more. Okay, the more compound, the more money. So this is to apply this, all right? Maybe you already seen this in statistics class. Let's see this example. So this example is saying find the annual percentage yield by an investment that earns interest rate 6% compound daily. So n equals 365, and rate 6% is 0.06. So after 1 year, right? So annual percentage yield. So principal times 1 plus 0.06 divided by 365, raised by 1 times 365. So that equals to, calculate this, we'll get approximately 1.06183. So the formula for simple interest is for simple interest. It's just P times 1 plus R. Right? Then we put an R in, right? So we just get 1 plus R equals this, or R equals this. That's how we find the interest rate by given certain conditions. All right, let's try some exercise. Let's try this one now. 1 and 2. Let's try this 1 and 2. So I'm going to give you, let's see, 10 minutes to do this. All right. Then maybe I'll call people to show. So 1 and 2. Okay, anyone wants to volunteer? Okay, Natalie, right. Let me make you a presenter.
Do I have to show my screen? Because I could just say for
Yeah,
one.
you can just see it for one. Go ahead.
Alright. Should I say it because I didn't take a picture yet. I'm just
That's
gonna say
okay. Right, just tell us.
okay. So for one, I said that the base is 5,
Yeah, the base is 5. Let me read for you here. 5.
and I said f to the power f negative 2 is 5 to the power negative 2, which is 1 out of 25.
1 over 25. Great.
And then f0 is 5 to the power 0, which is 1.
Which is 1, right?
And then f2 is 5 squared, which is 25.
Which is 25, right?
And then f6 is 5 to the power 6, which is 15625.
Huge number, big number. Great. Great. Okay. Good job, Natalie. And then anybody else? Okay, Rena wants to do 2a. Go ahead, Rena.
So like for a, it's f of x equals 2x. So the graph would be the number 3.
Number 3. Yes. All right. Anybody else wants to show it? Let me see who's here. James, do you want to try one? Kimberly? Kimberly, you want to try one? Hello, Kimberly?
Yeah.
Yeah, do you like to try one? 2b?
I'm gonna. I would be the first one.
The first one. Yes.
Yeah.
Yeah. Do you want to also try C and D?
Let's see. C, the second one, and D, the fourth one.
C is the second one.
Yeah.
D is the fourth one. Can you tell us the reason why C is the second one? Your answer is right. If you could explain to us why, I'll give you credit for presentation.
I don't have a reason. I just guessed.
Oh, just guess.
Yeah.
Okay, so you see negative, you see C, right? Negative 2 raised by x. So what's 2 raised by x, which is a 3, right? You see the all positive values because it's all above x-axis.
Oh, okay.
When you put a negative sign, it will go down below x-axis, right?
Right.
So that's why it's a 2. So do you like to try to explain D? It's a similar reason.
All values.
So which graph is 2 raised by negative x? Then you just negate the graph.
Will be 2.
No, you said C is 2, right?
Yes.
What about 2 raised by negative x? Which one is B? Because E is negating B. E is a reflection of B. If you can recognize B, Maybe you can see something about D.
Wouldn't it be the fourth one?
B, you mean B?
Yes. No, B, I said was the first one.
Oh,
Wouldn't,
right. B is the first one, right?
yeah, but wouldn't D be the fourth one?
Yes, you are right.
Reflection of?
Exactly. It's a reflection of 1 over x-axis. Basically, you negate 1.
Okay.
Yeah, okay. All right. Let me give you homework. So this will be homework 7. Let me write here. Oh, no, homework 8, right? Homework number 8. Let's do 3. Let's do 3, A and B. So let me actually write here also. 3. Okay, let's do this. 9, 11, 13. 3, 9, 11, 13. And this 15, 16. 15 and 16. 15, 16. 29 and 30. Okay, that's it. 29, 30. Okay, so this is going to be the homework. So this is chapter 1, 4.1, homework 8. 3, 9, 11, 13, 15, 16, 29, 30. All right, anybody has any questions? If not, I'll see you next Wednesday, all right? Okay, have a good weekend. Have a good weekend. I'll see you next Wednesday. Thank you.